This video is about angle pairs and the triangle angle sum theorem.
Alright, so some angle pairs, when taken together, have special names. Like number 1 here, vertical angles. So in the picture, next to this vertical angles, you see two lines crossing, almost to form the letter X. The angle 3 and the angle 4, one is vertically above the other, hence the name vertical angles. They form what's called a vertical pair. However, they don't have to be vertical because angles 1 and 2 also are called a vertical pair. So any pair that's across the X from each other, right? Any angle that is across the X from another angle is considered to be a vertical pair, even if it's not vertically oriented. So one special thing about vertical angles is that they're equal to each other. So angle 1 in this picture is congruent to angle 2. They have the same degree measurement, whatever measurement that is. That should be pretty obvious to the eye just from looking at the picture. And then, of course, angle 3 is congruent to angle 4. So that's what's special about vertical angles. Vertical angles are congruent. The next picture shows something called adjacent angles. Adjacent angles share a common side, or a common ray. So angle 1 and angle 2 in that picture have a shared side in between the two angles. And angle 3 and angle 4 in the other picture also have a shared side right in between the two. So adjacent angles just share a side, and they don't have any relationship between them necessarily. Right? They're not equal to each other necessarily. In the first picture, angle 1 and 2 are not congruent to each other. In the second picture, it looks like they might be, but it's just a vocabulary word you're going to want to know. Adjacent angles are two angles that are right next to each other, so they share a common side. So in fact, if you look up at the first picture where we have these vertical angles, there's a lot of adjacent angles there. Like angle 3 and 2 are adjacent because they share a common side. So adjacent angles is going to be an important vocabulary word that comes up in all kinds of figures. Supplementary angles are two angles. Let me write this definition. Two angles with a sum of 180 degrees. Two angles whose measurements add up to 180 degrees. So in this first picture, we have angle 3 and 4 right next to each other. Because they lie on a straight line together, they are supplementary. Their angle measurements will add up to 180. So if this, for example, was 140, this one would be 40. Together, they add up to 180. The second picture right next to it shows a 137-degree angle. And the supplementary pair to 137 degrees doesn't necessarily need to be attached to this, doesn't necessarily need to be adjacent to it. It just needs to be another angle somewhere, let's say right here, that has the supplementary measure to 137. So to find the measure, it would be 180 minus 137. So 43 degrees. And maybe I call this one angle D. And now I have angle C and angle D forming a supplementary pair. So just two angles with a sum of 180 that aren't necessarily adjacent to each other. Same thing with complementary angles. Only complementary angles, in case you can't tell from the picture, are two angles with a sum of 90 degrees. So in the first picture, we have angle 1 and 2. They're adjacent to each other, and they form together this 90-degree angle. So this little box in the corner means 90 degrees. So angle 1 plus angle 2, whatever they are, equals 90. And that they might be a 50-degree angle and a 40-degree angle, or maybe they're both 45 degrees, but together they equal 90. And then, of course, next to that, you see a picture of angle A and angle B not adjacent to each other, but they can still be called a complementary pair because the sum of 47 and 43 is going to be 90 degrees. So complementary and supplementary angles just talk about the sum, and they don't necessarily need to be adjacent to each other. A linear pair, however, does need to be adjacent. So a linear pair are adjacent angles that form a straight line. So this angle right here, ABD, is adjacent to DBC. Notice I put a single arc on one and a double arc on the other. That's just to show that their two angle measurements are not the same. But together, we know they must add up to 180 because ABC, the whole straight line ABC, is a 180-degree angle. So a linear pair, this is going to be a really common word in vocabulary, in geometry rather, very important word. Linear pair are basically adjacent, supplementary, and these are two words we've already defined, angles, right? They're adjacent because they share a common side, and they're supplementary because they add up to 180. So the adjacent supplementary angles, or you can think about them as two angles that form a straight line. Here's an algebra application of this. It tells us that, totally unrelated to any picture, KPL and JPL are a linear pair. If you know that KPL and JPL are a linear pair, I always would start by drawing a straight line with a vertex point in the middle. Now I just have to think about how am I going to correctly label this thing. So it looks like one angle has a K in it, the other one has a J in it, but they both have P and they both have L. So that must mean PL is the common side that they share. I don't know the size of these two angles, so I'm just going to draw this figure however I want, not necessarily drawn to scale. And the first angle I'm calling K, P, and L must be out here on the shared side, which means the other one is J, P, and then L. I can label it with the information given. KPL is 2x plus 24. JPL is 4x plus 36. Again, this figure is not drawn to scale. I might find out that these angles are, one of them's 20 degrees and the other one's 160 degrees, in which case my picture is totally wrong. But it's okay for your figure not to be drawn to scale. It's only there to help you solve this equation for x. It's asking us to find the measures of these two angles, and I know because these are a linear pair that they must add up to 180. Linear pairs are supplementary. Their sum is 180. They lie on a straight line together, and straight lines are 180-degree angles. Now I just have to combine like terms. So I have 6x, I have 24 plus 36. Subtract 60 from both sides. And x equals 20. Now it didn't ask me to find x. It wants me to find the measure of these two angles, so I will have to plug my x back in. So 2 times 20 plus 24. So this one ends up being a 64-degree angle. And 4 times 20 plus 36. So this one ends up being a 116-degree angle. And of course, that's not the way my picture looked, but it wasn't drawn to scale anyway. Those are the two correct answers for KPL and JPL. Another pair is a bisected angle. So you're taking this outer angle, which is in the picture angle XAZ, just traced over it in a black to make it a little bit darker. So XAZ is the outer angle, and it has a ray that goes right through the center of it to divide this angle into two congruent pieces. So the ray I'm talking about is AY, right? That ray goes right through the center and cuts XAZ into two congruent pieces. So this one has a red arc on it, this one has a red arc on it, to show me that those two pieces are equal. It's almost like a midpoint, but for an angle. So it's a segment, a ray rather, that divides an angle into two congruent pieces. Another relationship that's important to know about angles is angles inside of a triangle. And this is pretty common knowledge. It's going to have a lot of applications in geometry. It's important for you to know that the three angle measurements inside of a triangle add up to 180 degrees. So the measure of angle A in this picture plus the measure of angle B plus the measure of angle C is going to be 180 degrees. Now, none of these angles are necessarily congruent, so I should probably put a single arc, a double arc, and a triple arc, because each of those three could be different. When you add them up, it equals 180. So in case you haven't noticed, that 180 is going to be a really important number in geometry. It's the measurement of a straight line, and it's also the measurement of the angles inside of a triangle. How is this going to help us? So here's a figure. The question is going to ask you to solve for x, y, and z, find all variables. And there's usually an order that is best to go in. It's not necessarily alphabetical order. So here it is, because x is the only one we can find right now by looking at the information given. I can find x because I see the triangle BAD, triangle BAD, and I see two of the measurements already labeled, a 43-degree angle, a 59-degree angle, and the only one I don't know is x, And the sum of the angles in a triangle is 180. So to solve, all I'm going to have to do, combine my like terms, which is 43 and 59. 102 plus x equals 180. And subtract 102 to figure out that x is 78. So x is 78. How am I going to use that to find y? Well, I see that x and y are right next to each other, so they're adjacent, share a common side, and they lie on a straight line, so they're supplementary. They add up to 180. So if x is 78, and I can label that on my picture, then 78 plus y must equal 180. So there's that 180 again. Super important number in geometry. Subtract 78 from both sides, and y is 102. And how can I use that to find z? Well, now I see the triangle BDC. In triangle BDC, now I have two of the angles labeled. I have a 49-degree angle, labeled up at the top. I have a 102-degree angle that I figured out, because that's y. And to those, I add z for a grand total of 180. Again, I'm just combining like terms. 151 plus z equals 180. I put that little line inside of the z so that you know it's not the number 2. It's just a handwriting tip. And z comes out to 29. So you're using all of the relationships that we talked about to find missing measurements inside of a figure. It might get a little harder. Oh, first we got to cover this one. So you might have noticed in this previous example, let me go back a slide, that this 102 also occurred over here. And where did this 102 come from? It came from adding up the two angles that we had inside of this triangle, and it ended up being the same as this measurement, which was an angle outside of the triangle. That's called an exterior angle. So here in the picture, you've got two angles inside of a triangle, and another angle that's outside the triangle, adjacent to this unlabeled angle right here. So you've got two that are inside and one that's outside. And what we just observed from the previous example is that the measure of angle 2 plus the measure of angle 3 actually equals, in this picture, the measure of angle 1. And that's always the case for a triangle. So if you have any old triangle, let's draw a triangle over here. Okay. If I extend one of these sides, let's say I want to extend this side, to create what's called an exterior angle, it equals the sum of the two angles inside the triangle that are not adjacent to it. So any triangle that you draw, if you extend one of the sides, create an exterior angle, it equals the sum of the other two angles that are inside and not adjacent to it. So it may get a little bit trickier. We've got some vertical angles here, we've got some linear pairs here. All of those vocab words that you went over at the beginning of this video are going to be used to help you find missing variables. So quickly, I'll just go through and show you. A is going to also be 60 degrees because it's a vertical pair with the 60 that's labeled up here. Because it's next door, like A and B are adjacent to each other, and they lie on a line, they're going to add up to 180. So that means B must be 120, and therefore so is C, because it's across the X. So anytime you have one angle labeled in the X formation, you can get the other three, because of the vertical pair and the linear pair. And I can apply that in all of the corners here, right? This one's going to be 55 because it's a vertical pair, which means I is going to be whatever 180 minus 55 is. And so is G. In this one, I have E across from 65, so they're a vertical pair. And F and D are going to be whatever 180 minus 65 is. So it looked like it was going to be really complicated. Turns out it's not. It's just a bunch of vertical pairs and linear pairs. And then here we may have to apply our triangle skills and our angle pairs. So just labeling what I can right off the bat. I see this angle A over here going from left to right. I see this angle A is right next to a little box. I know that little box means 90. And I know that two angles that are next to each other like this must add up to 180. So if the left side is 90, A must also be 90. Moving across, we see this B. This B is a vertical pair with this 163, so it must also be 163. This C forms a linear pair with B. So B and C are right next to each other. They're adjacent. So if B is 163, C must be whatever 180 minus that is, which is 17 degrees. Moving over, I see a 70 right next to a D. They're adjacent to each other because they share this common side. So D must be whatever 180 minus 70 is, which is 110. And E is a vertical pair with the currently labeled 70. They're across the X from each other, so it must also be 70. So you'll be applying all of these relationships to try to find missing measurements in figures. Always look for linear pairs, look for vertical pairs, and look for triangles that add up to 180 degrees. And that is all.